Problem number 8-9. The linear operation Lx is defined by the cross product Lx equals b multiplied by x, where b equals 0 1 0 transpose and x equals x1 x2 x3 transpose are three-dimensional vectors. The 3 cross 3 matrix M of this operation satisfies the equation Lx equals m into x1 x2 x3, which is a column vector. Then the eigenvalue of m are, we have four options. Option A 0 plus 1 minus 1, option B 1 minus 1 1, option C I minus I 1, option D j minus I 0. We have given operation. Given operation is Lx is equal to b into x. Therefore we can write Lx is equal to b into x. We can write as I cap, j cap and k cap. We have our b vector as 0 1 and 0 and x as x1 x2 x3. Now this is our b and this is our x. Now we will expand this vector. It will be I cap multiplied by x3 minus 0 minus j cap 0 minus 0 plus k cap 0 minus x1, which is equal to x3 I cap and plus 0 j cap plus x1 k cap. Therefore we can write our Lx will be b multiplied by x, which is equal to Lx will be equal to x3 I cap plus 0 j cap plus x1 k cap. Now we have another equation. Now given in question that Lx is equal to m 3 cross 3 multiplied to a column vector x1 x2 and x3. Now we can see that Lx value we already know, and m3 cross 3 is a vector which we have to suppose, and this vector is already multiplied to a m3 cross 3. Now our Lx will be equal to, we will suppose a 3 cross 3 vector which is m11 m12 m13 13 m21 m22 m23 m31 m32 m33. This is our supposition. This vector is our supposition. This vector is our supposition. We have supposed this vector, and this vector is multiplied to a column vector which is x1 x2 and x3. This is a 3 cross 3 and this is a 3 cross 1, which will give us 3 cross 1 vector. Now Lx will be equal to, we will multiply these two vectors. It will be m1 x1 plus m12 x2 plus m13 x3. Now m21 x1 plus m22 x2 plus m23 x3, and finally our last row will be m31 x1 plus m32 x2 plus m33 into x3. This will be our 3 cross 1 vector. Now we already know our Lx is equal to x3 I cap plus 0 j cap minus x1 k cap. Our Lx is a column vector 3 cross 1, so we will take our this Lx vector as column vector, which will be Lx is equal to x3 0 and minus 1, x3 0 and here minus 1. This is a 3 cross 1 vector and this is a 3 cross 1 vector. Now both of these can be multiplied. They have given column vectors. They have given column vectors b equals 0 1 0 transpose and x equals x1 x2 x3 transpose. So b and x are column vectors, and cross product of column vectors is also a column vector. x3 0 minus x1 equals m11 x1 plus m12 x2 plus m13 x3 m21 x1 plus m22 x2 plus m23 x3 m31 x1 plus m32 x2 plus m33 x3. This is a 3 cross 1 matrix. This is a 3 cross 1 matrix and this is also a 3 cross 1 matrix, and this is our Lx, which we already know where Lx is. This is our Lx and we have written Lx as column vector. Column vector is Lx, which is equal to Lx. This is also a Lx. They both are equal, so we have equated. Now we have to equate Lx is equal to M, which is a 3 cross 3 matrix when multiplied to a x1 x2 and x3. This is our given problem. Lx is equal to M multiplied to a column vector. Now for our M vector, we can now Now for matrix M. Now for matrix M, this is our matrix M. Now for matrix M, equating LHS is equal to RHS. This is our LHS. Let us take as LHS and this is RHS. Now we equate both of them. So x3 will be equal to R1, 0 will be equal to R2 and minus x1 will be equal to R3. As x1 coefficient is M11 and left side we do not have any kind of x1 coefficient. Therefore we can write M as 0 0 1 0 0 0. Second element with second row. Now we equate third element with third row, which will be minus 1. This is our minus 1 and 1 0 0. As left side here we got 0 0 and 0. As we have left side all entries are 0, so right side all entries are 0. Now we have to calculate eigenvalue of matrix. Finally our M matrix, we have to calculate our eigenvalue. Now we have to calculate eigenvalue of matrix M minus lambda I is equal to 0. This is our M matrix, which will be 0 minus lambda, 0 1 0 0 minus lambda, 0 minus 1 0 0 minus lambda, which will be equal to 0. We will expand this matrix minus lambda into multiplied to lambda square minus 0 plus 1 0 minus lambda is equal to 0. Finally we have minus lambda power 3 minus lambda is equal to 0. Then we take common from lambda cube minus lambda. It will be lambda square plus 1, which is equal to 0. Now we can equate 1 by 1 with 0. Lambda is equal to 0 and lambda square plus 1 is equal to 0. We get lambda square as minus 1, which can be written as minus 1 can be written as I square. Therefore we can write lambda is equal to 0 and lambda is equal to plus minus I. Then finally we can write lambda is equal to 0, I and minus I. Option D correct.